Hello. Hey, Daddy. How's it going? Can you see me? Let me know if you can see me. Chat. Or Carlito in Discord. If you can confirm I am live. Okay. It's next stream. This one. Am I live? Carlito? Okay, perfect. Well, welcome everybody to this new live stream. Now it's the third week. The first one was failed, but now we're getting better. So yeah, I'm very happy to be here. Topic for today will be building a screener. Screener is usually something that you want to do when you want to get some data from the market, summarize it at some point, and then send an output. Usually you want to have those processes running. So for that, let me share a little bit our Discord. Is here. I think that, well, the guy told me I was saying S1KORR. Was really complex, but now seems like it's Psychor. So, well, I created this proposal. This is our Discord. If you are not in Discord, you can join. There are a bunch of channels where you can ask questions. There is a support channel. People is asking questions. The community helps each other. We have a Discord support program where you can join, and if you answer questions, then you get HBOT, the HBOT token, as a reward. Well, there are a bunch of channels. We also have developer channels. Well, there are a few things here. And we also manage things like proposals. As you can see here, there are a bunch of proposals. I created this proposal, didn't have too much success because only Psychor and Alan Coppola commented. It's okay, but I hope that in the future we can have much more people commenting here. Well, the main idea is that we were going to decide based on this, on the most voted topic to screen, what we're going to do today. I think that the one that has more likes was the one from Psychor, so we're going to do this screener. Then we're going to do probably the Alan one, or if Alan wants to add this to the PR, that will be also cool. Thanks for sharing your magic ways. That is a friend of mine. That is why he's saying that. But well, the thing about Psychor is that he proposed these things to start doing a screener. I move it already to this document so we can review it, and now we're going to start coding it. There are a few things that I'm going to code because, as you can see, there are a bunch of things that this guy wants to screen, but there are a few of them that is just reproducing what I did and adding more features to the screener. So my point here will be more like trying to show you how to put this into production with a few examples of this. And the exercise will be getting this understanding what has to be done to put a screen in production and leave it running a Docker container. So that will be like the scope for today. So screeners, I can divide them in like what is real-time screening. That is a process that will run forever. We get the candles, we get the order book, and then we'll send a report. For that, we can use Hummingbot, because for real-time is also very, very good. Hummingbot, you are going to have the connectors working, everything. And also, you can have a screener that gets the data all at once, every X amount of time. And then I'll put Discord here in case that someone is talking to me. And then you have like, as I mentioned, another screener that will be more like, instead of being real time, will be triggered every X amount of time. So depending on what you want to do, you can do either real time or you can do more like task base or like every interval. So, or like a recurrent task will be the right name. So well, today we're going to be first of all getting into a Jupyter notebook to compute all these things. Once we know which are the things that we would like to screen, we're going to put that into a task and then we're going to let it run. So well, let's get started. Probably can take a little bit more of time because I didn't review what we have to do, but I think that it's going to be okay. So the first thing is, I'm going to read what he wants to do. First time is real-time volatility index. So he wants to measure the instantaneous volatility of a coin to identify short-term trading opportunities. Parameters, time window. Use a rolling window matching your trading time frame. For example, the last 30 minutes. Volatility calculation, apply advanced measures like gauge models on high frequency data to capture volatility spikes. Okay, so the first thing will be computing volatility. How it's calculated, that will depend later on you. You can change it. But yeah, the first topic that we're going to compute is volatility. Then we're going to liquidity flow analysis. Tracks the inflow and outflow of the capital to assets, market interest, and potential price movements. Parameters, net flow metrics, monitor net buy versus sell pressure, exchange wallet balances, analyze changes in the exchange reserves to predict liquidation shifts. Okay, this is a little bit complex to match all the exchange balances, but what we can do is for a trading pair, we have the trading taker volume and the sell taker volume. So we can get the two volumes and make the imbalance of trading activity there. Then we have order book imbalance. Checks the depth of the buy and sell orders to take imbalance and might signal immediate price changes. Parameters, depth levels, how many levels we want, imbalance ratio, the ratio of the bid and ask volumes to identify. Okay, that is also interesting. I don't know if we are going to have too much information here, but we can definitely do it. Then we have funding rate analysis, the cost of holding long and short positions. This is really interesting. Having a funding rate screener is also something really good. Deviation, rate significant deviates from the norm, comparison across exchanges, spot discrepancies that might indicate arbitrage opportunities. Well, this is, I'm not going to do across exchanges. We're going to focus just in one exchange, so then you can extend it. But yeah, I like the funding rate one. Correlation breakdown detection identifies coins decoupling from the usual correlation with major assets like Bitcoin. Parameters, correlation coefficient, calculate over short periods, example 1 hour. Threshold levels, set criteria to flag significant correlation changes. Okay. Well, transaction monitoring. Well, we're not going to do anything from the wallets, so I will remove this. We're not going to do this one. So as you know, the initial patterns, price of volume, C-score, machine learning. Well, we are not. This is the same. It's like there are a few things that you can do. These are all very cool things, but we are not going to make it in 1 hour. Everything. So I will remove these things, and we're going to stay with a few of these things for the screener. So well, now let's understand a little bit the process of the screener. The steps are going to be the following. Let me go here and let me explain how we're going to do it. So the first thing will be, we're going to, when the screener starts, we're going to define the universe of markets. Yes? So this process is very simple. So we get an exchange, and based on the exchange, we're going to define which is the universe of asset of markets that are available. For example, we pick Binance Perpetual, we get all the perpetual trading pairs that are there. So then what we need to get for, first of all, we need to define certain configs. So the config of the screener, this guy is Secor, did a config for each of these parameters, but the screener task will have a general screener thing. So based on what he described, we can say that we're going to need volatility window, that's for the volatility index, volume window, so we analyze this net flow over a rolling period, how much buys and sells, like how much imbalance is getting the market has, comparing buys and sells. Then order book imbalance, we need the depth levels. Funding rate analysis is just the last one, so we don't need something here. We just get the funding rate, and then we get correlation breakdown. Let's say that is lagged the correlation, or no, I think that is like that. Yeah, let's just put like correlation. Correlation. Yeah, let's put. No, I think that we just need interval, like interval to measure, and then the correlation will be just the output of the value. So this will be the config for our screener. Then obviously that these metrics that we are going to compute can be improved, or you can change the way that you are computing these things. The important thing is how we are computing how the process is defined. So define the universe of markets. Then the next thing will be download the candles. Download candles. Once we download the candles, we are going to compute. Oops. This is going to be the next one. Will be compute metrics for each market. So the metrics for each market that we're going to compute are volatility, volume imbalance, or no, liquidity flow analysis, we call it. Liquidity flow analysis, order book imbalance, and then the correlation will be across funding rate analysis, and then compute metrics. Yeah, the correlation. Yeah, let's make the correlation against Bitcoin and correlation against BTC. Okay, Actually, for correlation, I have a few with my friends. We were doing a few screeners to identify markets, and we built a co-integration scanner, and we made a cluster to identify which markets are attractive. Actually, this is the, let me show you market selection. This is the output of the clustering. Yeah, as you can see, it's like, this is not what he's saying. He's trying to say, okay, how correlated is this market to Bitcoin, and if that correlation changed, that is what Cycore wants. But this is another example of how you can use correlation. Here what we did was we compared the time series, and we did the co-integration test to measure how the assets, if the assets are moving together or not, and then we group that into clusters. Some really cool things happen from here. It's like, if you check, for example, this observation that is 307 and 308, these tokens are let me show you, because it's really interesting. These tokens are these two, ZRO, and no, this is not working. Is this second token is SK. These were the two of them because we analyze it, and the great thing is that this analysis works because they are highly correlate. They're like very close together in the clustering analysis, and that is also reflected in the pattern of the price. So well, it's really interesting to perform like statistical arbitrage strategies here. But well, let's come back to our example. Well, so we define the universe of markets. We download the candles. For each candle, we compute all these metrics, and then we join. At the end, we need to join all the reports and output a table with all. And output a table. You understand what is this? And then optional, I don't know if you're going to make it, but at the end will be like sending the report, sending report, I don't know, we can try to do it Discord, I think, to Discord, or I don't know, we can do anything. Okay, well, is all clear? Any questions there? If not, I can start coding. No questions? Okay, perfect. Okay, let's start coding. For this, we're going to use Quants. I think that you already know the repo. It's in Hummingbot /Quants. Let's create a new folder, or well, I will put it here in market selection. I will create a new notebook. Here, let's put it screener. Let's call it Cycore. Screener Cycore. I will push it so later on you can reuse it. I will add the first line because we need this to. Okay. We need this for the ones that are running just in Jupyter. Okay. So the first thing, as we mentioned, will be defining the config. So the config has interval. Let's put it here. Interval will be equal to, let's say that we are doing 1 hour or 15 minutes. 15 minutes. Then we have, let's also compute the days that we're going to download. Let's download 60 days. Or 30 days is enough, I think. Then volatility window will be something like, let's say 100 or 50, I don't know. Volume window will be also like 50, let's say. And depth levels will be equal like let's say 10 levels, something like this. So well, now we define already the config, right? The next thing will be download the candles. So, sorry, before is define the universe of markets. So the question is how we can know what are all the markets that are available in Binance Perpetual. We also need to define exchange. I forgot that. So let's define here exchange or connector name will be Binance Perpetual. So let's say that we would like to know what are all the possible trading pairs that are available in Binance. That will be like saying, okay, tell me which are all the options that I can see here, because there are a bunch of them and I want to trade them and I don't know what they are. So yeah, team, after we finish the presentation will be stored live. So the thing is how we can know which is a whole universe of markets that are available. We have a component in Quants Lab called club. That club is for central limit order book. So if we get this club data source, sorry, I need to import it from core data sources, club, import club data source. So if we import this, now we can do a bunch of queries with the club, right? So one query that we can do is await club dot get trading rules for the connector name. Now you're going to ask, what are the trading rules, right? It's a common question, but it's something really important to understand. As you can see, if I plot here trading rules, you will see that nothing appears. It took a second to download, but these trading rules is, as you can see, is core data structure trading rules. If we inspect one of the under data, we have all these trading rules. As you can see, it's a list of trading rules, and what we can see here is that the trading rule contains the trading pair. This is something really important for us because it gives us the information of what pairs are available. The mean order size, this means that at least if I want to send an order, the order has to be 0.001 Bitcoin. That's important for a trading strategy because if you want to send an order of $5, it's going to fail. So having this information is very, very important. Then max order size, there is no limit here. Mean price increment, this is also something important. This says that the price can be incremented at 0.1. So if we go to the exchange and we go to Bitcoin, BTC, you will see that the order book here, this is a new feature from the Mac that is really cool. I can zoom in the screen with option. You can see that the quote here is point a number. That is exactly what this trading rule is saying. It's like this mean price increment at 0.1 means that if we check, for example, Ethereum, that the mean price increment is 0.01, if we go here and we put is there Ethereum, you will see that now we can be that reflected. It's like the price increment is 0.01. So well, all that information, if you are really new to algo trading, you are going to say, oh, I didn't know that this is something important. Yeah, when you build a strategy, this is really important because first of all, we determine what markets you can trade and what markets you cannot trade. And secondly, because it lets you design the strategy well, because let's say that you want to put a spread between orders. If your spread is lower than the mean price increment, your strategy does not make sense. So well, like that, there are like other things like mean notional size. This is the value in USD, so it's like at least we can send an order of $100 for Bitcoin. and also you have the limit of 0.01. So if we put 0.001 times 93, or I don't know how it's right now, but or 98, I think that is. It's almost the same value, but can differ a little bit depending on the price. Well, but the important thing here is that if we call the method to the trading rules get all trading pairs, we get a list of all the available trading pairs that are in Binance, right? So this will be the second part, that is define the universe of markets. Let's call it here like trading pairs is equal to this. Also, the trading rules has a few more features, like for example, filter by quote asset. So here we can only say only the ones that are quoted in USDT. And also we can filter by mean notional size and say we only want to trade markets below, I don't know, $10. And if we would get all trading pairs, this would be the new output of trading pairs. If we put at least $90, I can trade up to $90. We include all of this. If we put $110, now Bitcoin should appear. Well, it should be somewhere here, but yeah, that's basically these filters how they. This is yeah, it's okay. But well, let's come back to don't put a restriction here. Just filter that the quote is in USDT, and then we get all these trading pairs. So, well, the next thing will be downloading the candles, right? So we get all the trading pairs. Now we need to see how we can get all the candles for exchange. First, let's try to get one candle, and let's put that in a for loop so we can get all the candles. So candles is equal to await, and we can also use the club. If you're not familiar with async programming, this await is very important when you try to do things that will not block the program. Instead, it's going to be waiting for a response, and that time that you are waiting, you can do other things. So if you are going to do quant trading, it's really important to learn async programming. If you try to make a trading bot with synchronous programming, I would not recommend you to do that, because most of the time the bot is waiting for IO. So it's very important to do async programming here. So club get candles last days, we have that feature that has connector name, trading pair, interval, and days. It's completing everything for me. If I run this cell, you see that I am downloading the candles, and it took 3 seconds to download. How many we put? 30 days. 30 days in 15 minutes. So now we have this object candles here, right? Candles is here. It's also a data structure like it was the trading rules. See that the trading rules is also a data structure. This is because they have very cool features inside that you can use out of the box. Like for example, I can put that plot and automatically enjoy the candles plotted here very easily without too much effort. You can also put plot and put type equal to returns and see the returns of the exchange also. So this is something interesting too. Well, now that we know how to download the candles, there is another method that is called, let me put it here, await, or candles is equal to await club get candles batch last days. And the thing about this, like the difference between this one and the previous one, is that we can get the candles in batch. So instead of just getting one candle as it is, we get we are going to query a bunch of candles at the same time. There is a problem here because when you are sending requests, there is something called rate limits that basically is a restriction that the API of the exchange puts to you that says you cannot send more than 100 requests per second, let's say. Well, for that, you usually code a component called throttler, that the throttler is going to measure how many requests did you send already, and based on those requests, it's going to say, hey, you cannot send another request, let's wait a little bit, or it's going to say, yeah, you can send the request, so go ahead and send it. The problem is that that component right now is at candle level. That is an improvement that I have to do in Hummingbot soon. That will be having a global throttler that manage all the requests. But for now, that component is at candle level. So if we want to do this without restrictions or without batch size, we are going to end up with problems. So just to make a quick computation, we need to download 30 days of 15 minutes. So how many candles are in a day? So 60 times 60 minutes times 24 hours. We have this amount of minutes divided by 15 is 96. So 96 times 30 days is 3 requests per market. So it's not a big deal. So if we go to the docs of Binance API docs, let's see how many, what is the rate limit of Binance candles. This is something that we do just once, but in the future should be fixed by default. And also this is only to increase the speed of the download and put it at the maximum level that we can. Market data endpoints, K-line, limit weight. So we are going to use 5 of the weight, 5, and we can send, let me go to constants, Binance perpetual constants. So we can send 2000 requests weight to, this is per minute, 2000 divided by 5, 400. Yeah, I think that we can download everything at once. But well, let's put a small sleep. But yeah, so this was just a quick calculation, but the thing is that we need to define the batch size will be equal to, let's say, 20, and the sleep interval will be something like, let's say we're going to sleep 2 seconds. So here we can pass batch size and sleep interval. Okay, so if we run this method, let's see if we have any errors. Downloading all the candles, all okay. These warnings that I'm receiving here is because I didn't, the connector wasn't closed, so that's a problem. But well, it's getting the calls, start, the candles, stand, okay. Batch number 2, batch number 3, batch number 4. Batch number 5. Actually, if it's 3 candles times 3 requests times 100 candles, yeah, it will take like 3 minutes, I think. Okay, 7. Okay, we're in the middle. Well, this takes a little bit. I should, I think, increase the batch size, something to 40 or 50, I think, with 50 or 40. 40 will be okay too. But well, this is something that I shouldn't manage manually. This should be something that at some point is automated with a global throttler. So well, for now it's as it is, but in the near future will be ready. So well, once it's finished, let's start reviewing what we're going to do next is compute metrics for each market. So we need to compute the volatility that we can use AI to compute this volatility index. Rolling window matching your trading time frame. Okay. I don't know if Psychor sent me this computation. Volatility. Rolling volatility. Okay. How this will work in production, I mean getting the candles and computing features. Yeah, right now we are doing the research here, but then we're going to put this into a Docker container that we can execute this every X amount of time. So let's say that we can execute this every I don't know, every 15 minutes or every 30 minutes. It's going to get all the candles and compute the candles. In the next step, what we can do is to, instead of getting all the candles, just get the missing candles and compute it from there. Or the other thing is that there is already a task here in the tasks that is called candles downloader. So this candles downloader, if you check the file, what it's doing is you have a timescale database that here in Docker Compose DB, you have this timescale DB. So once we have this timescale DB, what is going to happen is that this task that is going to run will download for this connector all these intervals with a retention of 120 days and filtering by mean notional size of $10. And what it's going to do is going to go and download the candles, store in the database. And to download the next candle is going to get the information of the last candle downloaded and will download the missing ones. So that is why this task will let you have your own database of candles that then you can query very fast and use the screener from there. Probably we can actually change the screener to use the database, and I can just start the task. So yeah, let's do that. In the meanwhile, that will be faster. So I can start this container. Let me stop the gateway container. Backtesting runner. I have backtesting running. I will stop the backtesting. I have the timescale DB, and I'm going to start the candles downloader. So here, let me see. I will not use. Yeah, I think that these time frames are okay. It's going to be okay. Let's analyze the database, what it has right now. So if we go to candles DB here, timescale DB, let's refresh it and see. Well, we have a bunch of candles already. So let's download the candles. Let's start this task and see what happens. To start this task, you can just go to here and run candles downloader runner, and this will download the task. How you can configure this? You can, yeah, I know that is really cool. You can also have you also have a trades downloader, so you can also download trades. That is also very cool because then you can build any type of candle from the trades. But here, this candles downloader has this time delta 1 hour. This means that this process will be triggered every 1 hour. So if you want, you can even reduce the frequency, like let's say, well, so it will be like increase the frequency, so you can get the candles, let's say, every 10 minutes. So that is very cool because it's going to check what are the missing candles, we download all the candles, and that will be all. So as you can see, once the container starts, see that it's fetching candles for BNB in 5 minutes, fetching for 1 hour, 1 minute. So it's fetching the missing candles, just appending those candles to the database. And it's running a container, so it's better than running from source. So yeah, going back here to the notebook that we were playing around, it finished. It downloaded all the candles in 5 minutes, 30 days. It should be much more faster, but well, in 5 minutes you get the, if you don't have any candles and you want to just start doing some research, in 5 minutes you can get all the candles of 30 days in 15 minutes from Binance Perpetual. So if we inspect now what we have in candles, see that each of these candles is a data structure. If we access to the first one and we call the method plot as we did before, we also get the candles from here. We can get the second one, we can get the third one, and so. And you have automatically in a Jupyter notebook all the candles available for Binance Perpetual to start playing around and do whatever you want. So the first thing is that we need to generate a report right now. So the report will be getting this data structure, doing a computation of volatility and the rest of the things, and appending to a general list or a general list, a dictionary with the trading pair and the information of the metrics that we want to compute. So we are going to do a for loop here. So here will be for candle in candles, and we're going to do trading pair is equal to candle dot trading pair. Let's print this just to start to see that it works. So let's call it here like report is equal to this. And the first thing that we need to do is to compute the volatility. So df is candle.data. This is a data frame. And then we get for volatility, Sycor sent this code. So I will copy and paste the code that he sent. That is, first of all, calculate the log returns. So I'll put here import numpy as np. And this volatility window is something that we have from the config volatility window. So this is the first thing, computing the volatility, and we are going to get the last value because the report is something. This is something really important. At the end, the output is a table with these trading pairs. Each trading pair is a row, and each column is a metric. That is what is a screener, because you want to compare a bunch of markets in different units of measurement. That can be volatility or whatever. So the first thing will be saying df volatility is this, and let's say volatility is equal to the last one. So let's extract this into a method. Let's put volatility is equal to get volatility with a df, and this def get volatility df, and let's play this and put return. Okay, then what I'm putting this as an independent function. So then if someone wants to improve it, just change the function and you will be ready to improve it. Now the next thing that we need to compute is the volume. So he sent me, did he send the imbalance at somewhere? I'm checking the chat because Psychor sent me on Discord historical funding rates. Well, don't worry because I already have a feature for volume. I will copy from the features. So features, candles, volume. What I did here was, first of all, I computed the volume in USD, and then by taker volume and by sell taker volume and the imbalance. So we have an other rolling metrics. Rolling. This is a rolling imbalance. Buy say imbalance, rolling window. I think that this makes a lot of sense. Buy sell pressure. Okay. I think that this makes a lot of sense. So I will just add this. Why have the long window and short window? Let me see. Because I am in the metrics for a long window and a short window of time, but we can just use one window here. Yeah. Rolling buy sell imbalance. Okay. Yeah, but let's take this part at the beginning. Very simple. But then you have that into the features of candles, so you can improve it as you want. So let's put like this. This first part, what it's going to do is to get the buy taker volume and the buy and the sell taker volume. Why? Because if you check, let me show you candles data. Let me show you what is inside here. This is the data frame that comes with the candles. As you can see, we have the volume. This quote asset volume should be already the volume in USD, but I'm doing volume times close, and that is the volume in USD. And then we have taker by volume and taker by quote volume. So if you check what I'm doing here is saying volume in USD is volume times close. So this times this. By taker volume USD is a taker by base volume times the close. That should be also this value, but I compute it just in case. And then what I'm saying is the sell taker volume should be the volume in USD, that is the one that we computed, minus the taker by volume, because the volume is just one. So we have taker buy and taker sell. And the buy sell imbalance is buy taker volume minus sell taker volume. So this imbalance, if it's negative, means that there is more sell pressure than buy pressure, and if it's positive, it's going to be that there is more people buying at market than selling at market. So at the end, what we can do is to put a rolling and say window is equal to volume window, and then calculate roll on total volume. Okay, perfect. That will be the rolling volume. Actually, I think that I can just avoid putting window on window, just like this. No, I can just put like this. window. No default. Just put it like this. Window. And okay. And then let's return the last one. Return. Like this. Okay, we return the last one. So this will be volume imbalance. Volume imbalance. And the window will be volume window, and here will be volatility window. Well, what's next? The next thing will be order book imbalance. Yeah, so we need to get the order book. I don't know if the club has already I don't know if it has already the get order. We don't have the get order book. Here we need to implement the get order book here. For now we can hack it as let me hack it. We need to add that. I will add it to the notes. Wait. Well, I will put a to do in the club. Club. Let me put a to do. Order book snapshot method. Okay, we need to add this method, but for now let's try to hack it here. So let me go here and get a connector. So connector will be equal to to club.get connector, connector name, connector get this was going to be exchange by base, so I can get from Hummingbot connector exchange, import exchange by base. With this I will get the type hints connector that get order book for, let's say, BTC USDT. Wait. Okay, no order book exists for this. So let me check what method. Request order book. Let's go to Hummingbot. Order book snapshot. Let's go to exchange by base. Order book tracker. These are the things that are very Hummingbot oriented. Let me put request order book snapshot. Let's check this one, for example. Return data is in a data source. So this is going to be a hack. Later on we should expose a better interface, but it will be like data source or order book is underscore exchange by base order book data source. Okay, this one should be order book data source. So now you learn request order book snapshots. No, the method was snapshot for a trading pair. Oh no, this is the okay. Let's just try it like this. Oh, wait. Okay, we have it and we get it, but this is going to be very custom for. It's not something that is built in right now in the connector to get a snapshot from a query, because just to explain you why not, Honeypot is intended to be an application that is running. So when you start the connectors, they initialize a bunch of things that you will need to have for having a bot running. That is like creating the order book structure, getting the information via WebSocket, sending some snapshots via REST, all that stuff. That's why this method is not public, but I'm planning to do a refactor to start exposing some more like a public interface to get these things without a bot, a connector running. But well, in this way we hack it and we get it. So what he wants to do is to measure the imbalance. So the output of this is, let me put here, OB, it will be equal to this. And let me write again. So OB dot keys, or what is this? Keys. Last update, it's not processed. So request order book snapshot. And then we have this. Okay, we have this method, order book snapshot. Sorry, we can use directly this one. That is order book snapshot. And this OB now is an object of order book snapshot type order book message. So OB dot asks and bits. Okay, so we get the asks, let's put asks bits is equal to OB asks OB bits, and then asks is this. So we have this order book row, and if we loop, this is incremental, and he wants to have a depth. So with the depth, we can depth levels, multiple levels, and imbalance ratio, the volumes. Okay, so let's put it like cum ask volume equal to 0, depth, or yeah, let's put 4. No, I think that we can just do sum of row times amount for row in asks from like this. I think that this should work. And cum bits volume is going to be the same thing. And if this works, will be amazing. Cum bits volume, perfect. Yeah, it worked. Cum ask volume. Okay, we have an imbalance here. There is more bit pressure than ask pressure. I think that we can just do it like this also. OB bits and OB asks without unpacking. And we need to measure the imbalance. So the imbalance, how he said to compute the imbalance, ratio bit to ask to identify. So okay, that was compute bit ask ratio imbalance. Copilot. Come on, Copilot. I don't know if computed it like normalized or how to compute it. Oh wait, is cum bits volume minus ask volume divided by the sum. I think that this is okay. Yeah, perfect. The same stuff. So let's call it imbalance like this. Okay, so now we just get def get imbalance for a trading pair, and this will be this stuff. This stuff from here. Let's remove the type hint because we already have it. And then we need to compute this stuff over here. Okay. The thing is that I don't know if this is going to take a lot of time for each row. So maybe it's better to do it all at once. I don't know if I'm going to be rate limited, but let me try to do it all at once. This is async def. Async def, get imbalance, and then this is return. Because I think that took like 1 second every time that we get a query. So if it's 400 markets, it will be like 400 seconds. So it's a lot of time to wait. So let's see if we can do it all at once. This will be, let's copy this function, and let's say, I will explain why the difference between do it all at once and one by one. So let's say that we get like 10 trading pairs. TP is equal to trading pairs, the first 10, right? So if we do 4, that is what we are doing for trading pair in trading pairs, get imbalance, print imbalance. Let's see how much time we take to get the 10 trading pairs. So this is very annoying. If someone wants to work on filtering warnings or something like that, it would be really cool. But yeah. So as you can see, it took to get the first 10, 16 seconds. So it's more than 1 second per go. But what we can do is to do the following. Is like this. Tasks is going to be get imbalance, trading pair for trading pair, trading pairs. And now we can do imbalances, async IO gather, and that will trigger everything at once. Import async IO, and now we move it from 16 seconds to 2 seconds. Now the question is, can we do it for all the trading pairs? That's the next question. So let's fucking do it. Trading pairs. Maybe I'm going to be rate limited here, but I don't care. Okay. Yeah, here there's no problems with rate limits because yeah, too many requests. I think that the rate limits are not working well in Binance. The throttler is not working well. We should check this. But yeah, we were almost there to do it. Memento says there was several efforts to remove these warnings, but it requires quite some changes. Yeah, I know that requires a lot of changes. That's why I think that it's just a warning, and it's how we are closing the connector. But I think that if we make the change, that this is a big change. That is like managing the sessions and the throttler more as a global level. And when the bot starts just passing a session, and then with like a context manager, it will be better. But yeah, so seems like the throttler is not working very well for the depth here, but I think that we can do 2 batches, and in 2 minutes we can get everything. Yeah, I know we have this discussion always, but there are some changes that has to be under certain standards to really fix it. But I was saying for these warnings, like in the notebook, because I think that in the notebook there is a way to configure to avoid these warnings, because in the client we shouldn't have these problems, but it's more in the when testing the notebooks or the tests, we are receiving these warnings because we are not closing the connectors. But there is a way in the notebooks to filter these type of things. So yeah. Well, let's do 2 batches to get this. So it's trying to make 2,400 requests. I don't know why it's trying to make too much requests here, because we just need to be doing how many trading pairs we have. First of all, check that. Then trading pairs, we have 318. Should be only 318 requests. This order book thing, or we are order book. This is something to really understand, why we are making this amount of requests when we just need 300 requests. So there is a problem here that we need to fix, because it's not okay, balance. Let me see the order book snapshot method from Binance. Maybe it's the time synchronizer that is trying to make requests to the time. But let's see, depth, or the Binance perpetual snapshot rest URL, 1 minute. The weight is 20 here, but it should be limiting how much we are sending. Well, we need to review very well this part of how we send the request. For now, let's do it in 2 batches. So will be 4E in range 2. Let's get our let's put end trading pairs is equal to len trading pairs. Let's put here like batches is equal to 2 and 2 batches. And now all imbalances is equal to this. All imbalances, extending balances, await is in Kaio sleep. Let's sleep, I don't know, 10 seconds. Let's continue. Okay, let's see if now works. Oh, no, I will be, no, fuck, I am banned. Because the other request, I probably need to wait some time. But yeah, I'm fucking banned. Could not refresh. Yeah, there is a problem with the time synchronizer. We are trying to make requests with the time synchronizer. That's why it's failing. But well, we can continue this one from the order book another time, so we don't block the original idea of this, that was getting the screener up and running. So here will be this part that is add a method for order book that I have a to do, that is review the time synchronizer and why it's failing, or if we can disable it at some point. But yeah, it's something important to review. And get volume imbalance, and then we get funding rate analysis. Well, these next two things, you can get them as I did for the other things, but we already are like more than 1 hour of live stream, so let's see how we can put all of this together into one screener, and then you can continue and add the next of the things. At the end, what we need to do here is to report, append a dictionary with these things. So if we run this cell, we will see that if we call the report, or we put pd dot data frame report, import pandas as pd. If we do this, at the end we get this report that this should be like our screener. Is like at the end, what is missing here are more columns related to the features that you want to compute. But that is the flow, right? So we are up to this point. We define the universe of markets, ready. We downloaded the candles, ready. We compute the metrics for each market, ready. We join all the reports and output a table, ready, and send the report to Discord. This probably can be the next week. Next week we can send the report to Discord and automate few of these. But this is like the full end-to-end stuff in a notebook on how to do this. Now the question is, okay, let's say that I want to put this into something that runs every X amount of time and outputs the values somewhere that I can get it, right? So it will be missing the part of sending the report through email or whatever. That part is missing. Actually, there is here one task that shows you how to send a report via email, so you can reuse something of this in case that you want to send an email report. But for now, let's copy a simple task. Let's create a simple task. Let me copy and paste this and put screener task. This guy is Psychor. Screener task Psychor. Probably we can continue it next week for seeing the reporting. But I will put right now a base stuff or a base config of how we can. This password is someone. Report generator task. Let's call it here data reporting. No, this would be screener Psychor task. Let's call it as it is. Well, this is in case that you're using the backend API. You get information from your active bots. You can add that to your report. For now, we are not going to use it. Well, yes, we are going to use the timescale client. We have this function to execute a query from the timescale client. We are not going to use the emails. We are not going to use these emails. We're not going to use neither this email. I'm going to remove this. We're going to test this task as it is. And backend API host, we're not going to use it. Export true, no. Export no. No. This is the only thing that we're going to use, the timescale client. And the only important thing that we need to do here, we are not going to see this neither. The only important thing that we need to do is to code the method execute. So this, how this task works is like you have tasks that have a method called execute. So there is a task orchestrator that will have different tasks, and each task can have a different frequency. So depending on the frequency, this orchestrator will say, okay, it's time to trigger this task. It's like an airflow, but with a very simple logic that just execute tasks based on a logic. So the only thing that we need to code here is the async execute. It's a async execute. Async def. Sorry, async def execute. This is the only method that we need to code. That, as you can see, the base class does not have this implemented, but is the one that we need to implement. So in this execute method, what we need to do is to, first of all, we need to reproduce all this stuff that we have here, right? So if you want to do it with how we did it in the notebook, we just go here and we copy this to this task. Oops. We copy this here. Well, this should be in the config. We should send the config at some point. This should be part of the config actually. Should be here. Connector name. Connector name. What else? Interval days. Interval 15 minutes, days 30. What is the window and volume window? Perfect. These are the things. Memento says there should be a protocol definition somewhere. Yes, if you want to contribute Memento and add the definitions, feel free to do it. I'm trying to do it as much as I can, but I'm doing this almost alone. So if you want to contribute, it's open source, so anyone is invited to contribute. Well, let's come back here and get the club data source. Well, in this case, we have this timescale client that is a database that we generated here. So if we access one of these columns, you will see that we have all the information. So we have two options here. We can either get the candles from the timescale client, or we can get the candles from the exchange. So what we can do right now, because in order to get the candles from the database, we need to use this timescale client, and you also need to have this task that I mentioned. That is a task that downloads the candles automatically for you. As you can see, it's still fetching the candles, 200 from 345. So it's still fetching candles and updating our database. So this is something that will run and will keep your collection updated. If you don't care, that can be like a minimum distance or whatever, or you can improve even the task to get the candles from the database and collect the missing ones when running the screener. That's another option. But those are like the two possible ways to make the screener. I would recommend to set up a good infrastructure in a local database. So if you have this infrastructure here, you don't need to worry about rate limits or taking time to download the candles and everything. That would be a very good solution. Mainly, or why I recommend this, is because imagine that this is one screener that you want to create. If you want to create another screener later on, what will happen if you are not using your own database? You're probably going to resend the request to the exchange, and then you're going to have more problems of rate limits. So the best thing that I would recommend is to set up this database with and start streaming and storing your data, and the screeners are going to only consume the data that you get that you generated in your database. That is my recommendation. Or you can get the data from the database plus append or just get the missing things that you don't have in your database. So well, in order to summarize this, we're going to download the candles. So to the universe of markets, so we can say available candles. Oh, I don't know why it's like this. It's going to be self.tsClient.get available pairs. This returns get available candles. I think that is get available candles. So this method will return the available candles. It's async, I think. Await get available candles. And what we have here is what we can do is to get these candles. So what we can do is say candles or get or candles tasks will be equal to self.tsClient get all candles connector name trading pair interval for connector name trading pair interval in available candles. I think that should work. Once we have all the candles, we are going to omit this part of the trading rules because this part should be included in the candles that you are downloading at some point. And well, here get candles batch. Okay, now we only need to code this part, that is the report. The imbalance, as we mentioned, we are going to not do it. We need to import numpy here. Fuck. Numpy is here. This is not needed. Okay. So we're going to get all the candles. Connector name, I did a mistake here because I need to also put a restriction if interval is in conf interval and put it here down here. So it's and I need to filter by interval and connector name in connector name. So these are the two things that we need to filter the candles that we are going to get. And then these methods can be abstracted in a features class, as I did in the core features. You have all these features here. I will probably need to do a big refactor on this code base because, as I mentioned, it's a code that is not part of the official Hummingbird suite, but yeah, it's something that we are building. We want to encourage people to use. But well, so for now, let's leave the functions here and let's change this to self.config.get volatility window and self.config get volume window, and then let's just for now let's print the report or logger login.info. Let's print report. Yeah. Okay. If we run this, So the thing is that once you define a task, the task can you can debug the task here. So if I run this here, what says at non-type has no attribute acquired. Okay, this is the first problem. The thing is that the pool is not initialized. That's why when we call the method execute, we need to put await connect. I forgot to connect the client. So now if I run it again, loop does not support argument 0 float. Okay, first let's debug, because I don't know if these things that we are doing are okay. So let's debug a little bit to understand what is happening. So available candles, we have this bunch of candles. So probably at first filtered candles, let's yeah, because it's a tuple. Let me see. If I run this, let me see if I can filter all the candles. Yeah, now it's filtered candles. I can remove this condition from here, so it's cleaner. Now I think that is cleaner. Let's restart again. Oops. Let's restart this again. Okay. Filter candles. So we get this stuff. The candles task is this. Let me see what happens after we run the candles tasks. Okay, loop. Well, seems like it does not like this way of doing this stuff. Let me see if I do await self.ts. Let's do it the old way just to see if it works. For this stuff I want, candle like this. Let's put all candles is equal to this, just to validate that that method works. Let's restart this. Candle is not defined. What's to be? Let me see if all candles. Yeah, all candles seems like it's working. Oh yeah, I have all the information. Okay, perfect. So let's call it these candles. Perfect. Candles. Okay. Well, let's come back again. And I think that now should work. If I run this, you funk. Okay. Yeah, I know. The problem is in this get volatility. Let's put a breakpoint here to see it correctly. df is this. Let's see the data frame. So this is the line that is failing. Loop or func does not support argument 0. df close. So the problem is with the numpy log, I think. But the strange thing is that before it was working. Let me see this. Where's the output of this? Loop or ufunc does not support argument 0. No call. Does someone know this error of np? Let me just try to isolate this here. Static method, let's isolate these things here. Nothing to do with this, but static method just to clear up. Okay, let's run it again and let's debug here. But seems like we are having an issue when computing the log returns. Loop or ufunc, let's Google it. Let's see what ChatGPT says. Okay, we have the first one that is known. Let's see the D type. I think that, no, maybe you know. df close D type is object. That's the problem. I need to improve the timescale client because it's an object type. So what we need to do is to put df close as type float, ds volume as type float, and then the rest of them. But yeah, the problem is the type float, I think. Plus the other problem can be the first one that is, yeah, but it's not the problem. The other one was it the type. The type was a problem. Oh, another problem. And decimal and float, okay. Taker, get volume imbalance. Yeah, we also need to do it for the, there is something that is decimal, what the hell? Goes volume USD, where is, okay, let's go here. But some of these taker by this one I also need to put. Okay, I think that's basically all. No, it's not a drop NA. It's something that when I'm storing the things in the database, for some reason I'm storing them as a decimal, and that's a issue. If I have it in decimal format, it's not going to work well. So here, if we put print pd dot data frame report, now see that how fast it works, and we can even go faster because I did the loop to get the candles because I thought that was failing when getting the candles, but seems like the problem wasn't there. So I'm requesting the candles to the database in a for loop that should be much more slower than than when doing AC and Kaio gather. So I think that if I do this, let's do it even faster. So I like to do fast things. So let's do candles tasks is equal to this, and then candles is this. This should be even faster than the previous one. Yeah, well. Okay, let me see how much time we take, because it will be good to see how much takes to time before start. Let's put equal to time. Let me do something like this. Yeah, well, regarding to augmented, it took 2 seconds to do all the screener. That's a very good question, a very good intervention, Memento, because I will ask you for a favor that is doing a comparison, because you already did the improvement to have the augmented pure Python in the code base. So I will challenge you to make a comparison of performance of the backtesting. If we run the backtesting with pure Python as it is right now, and adding the augmented pure Python. Oh, I just almost dropped. And the augmented pure Python, and see the performance, because that's something that I really need, and I think that is really important to have it improved. So if you want, then we can discuss in Discord which are the classes that I think that you should be improving. And we're actually working on this PR that I removed some of the backtesting that is some part of the backtesting that were redundant. I don't want to move it 100% to Python in case that there is an extra change. At some point, I will want to make it everything in Python for the backtesting to make it faster. But for now, inside strategy v2, in backtesting, the things that we should be doing this augmented pure Python Memento are this backtesting engine base, that is the simulation of the executors, and the executor simulator base. That is when we can do it just all in Python. It's very simple. We can do this all in Python. And the two important ones to do is this DCA executor simulator and position executor simulator. So these two plus this one plus this one pure Python. If you can make a proposal to move those to augmented pure Python, will be really cool. The thing is that to test the performance, we should perform a backtesting. So you can use a research notebook, or you can create a task. There are a few tasks of backtesting here that you can use and compare the performance. The thing is that in order to use it, you will need to build the wheels locally from your Hummingbot, install it in Quants. If you don't know how to do it, it's very simple. You need to install wheels, and there is an Notion doc with the steps. But then you can put here, instead of Hummingbot, you can put the path to where your wheels are. So well, nice that you did the Coinbase in augmented pure Python. Then profit pathways says, okay, we can work together on that, Memento, and I can show you how to use it. It's very simple. Profit pathways FX says, how much can you average on returns using this screener? What are your personal results? Probably profit pathways you were late to the stream. At the beginning we talked about how we designed that, but basically it's not something that I use. It's something that we proposed here in the proposals. So the idea is that every Friday we do a live stream and I show how to do something, And in this case, the proposal was to let the community decide what screener they want to build. So Psycore proposed a screener, and what I'm doing is what the community wants. I'm trying to translate that into code and something that we can use. The next week, probably we're going to continue and add the send email feature, so you can see how you can receive an email with the screener, or if you want to propose another platform to get the screener, we can do it in another one. And the other idea that we have for the next stream was to start showing how to use Solana with Hummingbot and start trading on Solana, placing ranges, trading meme coins, all that stuff. But well, that's why this screener is something that just shows the volatility and the volume imbalance, and then you can take decisions based on that, but it's just that. Well, the next thing, we already have the task and it's working the task. So that means that we are printing the value and how much time it takes and all that stuff. So with this, we are just running this task. The thing is now how we put this into production, because we need to, at some point, have this in an automated process that runs every X amount of time. As you can see here, the only thing that we are doing with the task is to run the method execute, and that's all. But there is another structure that for now, this is very unstructured. I would probably create a type of that's why it's work in progress. I'm testing out different ways or how is more convenient to manage for user tasks. But I will probably at the end just have a YAML file with the name of the task that you want to run, the frequency and the config. So you just define a few YAML files. There's going to be just one orchestrator that reads the YAML file and triggers everything for you. But for now, the only thing that you need to do is to have a runner, like for example, this. Let's use this. Copy the candles downloader runner, or we can add it to the candles downloader because we are already downloading the candles. So if we downgrade the candles to download every 10 minutes, we can also go here and copy the name of this task that we want to run. So instead of candles downloaded, this would be data generation runner, whatever. So what we need to do here is to say screener Psycore task is this. Every hour or every, I don't know, 5 minutes, we can, well, it would not make sense, these minutes. Let's say that we update the candles every 5 minutes and we generate this report every 10 minutes. So we import this, and then the next thing that we need to do in terms of config is to define the config for this one here. We move it here, and then well, we can append the task here, and we can append, let's put like, to don't confuse, candles config, candle downloader config, and this is going to be screener config. Okay, and now let's add orchestrator, add task screener config. So this is like the setup. So now what we are saying here is that besides having a container like this one that will be downloading the candles, we'll also download, besides this, like downloading the candles, we'll also run the screener and generate this report. That for now is just printing. We are not doing anything fancy. We are just printing the report. But that's basically how you can put it in production. So well, that's basically all. If you want to run it, we can just like keep this container. Let's start with the screener, so we know that it's going to work like that. So if we run, if we run the Canvas downloader backtesting runner, now you will see, oops, it's failing. What says? No module name task. There is a problem here that we are importing this up here, and we should be importing this here. Is inside the dev main. We need to import this. That's why it was failing. But this is why this is work in progress. I need to really work on the architecture of the tasks module. But well, see that is working. The Canvas runner now is working. Starting Canvas downloader. Well, now it's going to run like the two things in parallel. And the thing that is missing is the reporting that we didn't add, but we need to do it. But well, if just to avoid all these logs, if I comment here the candles thing, we can just see only this task running. Yeah, and I need to, sorry, I forgot also that this task, instead of this, will be logging.info. But well, basically that's the whole flow. Now with the print in Docker will not work. We need to use the logging. So as you can see, is providing this report, generating the report and printing the report here. The next thing will be sending the report somewhere. If we want, I can even, let's put seconds, so you can see that works. So we can generate the report every 10 seconds. So let's put this like this. Yeah, Droopman in the chat says that in the next live streams we should include the portainer monitoring tasks. That's really important. Good call. Because here I'm using PyCharm, that is amazing. Well, see that now 10 seconds and the next report is generated. So now you believe me when I said that this task orchestrator works and makes this one after one every 10 seconds. So that time delta will help you. Yeah, what Druman is saying is very important, is that there is this thing called portainer that you can run as a Docker container. It's actually pretty amazing because, well, also it works with Kubernetes and all this stuff, but you can see the containers all over the, actually let me run it, portainer Docker hub. If I go here, community edition, I think that this will be enough. If I run it here, just to show you how it is, Docker run portainer will download the thing. Well, the thing is that it lets you monitor a bunch of containers, and something that Drupman found yesterday is that you can attach the terminal. That usually, if you're using Hummingbot, you want to attach the terminal too. So that's something really cool. It's downloading. Seems like I need Starlink if you want to help me. Okay, let me see. Okay, let's wait. What port is this, Drupman? In what port by default goes? $8,000. Okay. Yeah, I think that some of you know, but I work with Drupman, Blas, and Ilmunie in a hedge fund. We have a small hedge fund, and we are doing a bunch of these crazy things. Today we're going to put into production a new strategy that we're working on that is fucking crazy. I posted in Twitter a little bit about it, but it's this. Let me show you the design. We are finding peaks. Well, it's here I was doing some changes, but on Twitter I was posting x.com. I posted the this one. It's like I call it a peak finder that basically, based on prominence of the peak and distance between peaks and a few things, identify the peaks. That is like this yellow stuff. So once it identifies the peaks, I'm using those to define the targets of take profit and stop loss. But stop loss, no, for stop loss we're using also Donkian channels. That is more short term. But based on these barriers, we're going to end up defining like a range to put like in a kind of grid, but it's more like a market maker that trades very hard on that range with a direction. So, well, today we're going to put a few of these on production. But the other day I put it to work like, and I think that it was in 8 minutes I traded like 30k USD with $100. So it was like crazy the amount of volume that we were generating. But well, let's see, it's already working. So 9 here says okay, Drupman posted the. With this should work as it is, like localhost 8 or 99443, no, or 8000. No, well, I will put the Drupman command. Oh fuck. I didn't download the community edition. I download the other one. But yeah, this is really cool because if you don't have PyCharm, that I would recommend to have PyCharm because it's the best IDE. You cannot have this stuff. This is really convenient because here you can, let's say that I want to kill this task, command delete, and I just delete the container, and it's very straightforward for development. I will start it again so we can still do the screener. Let's see if it's downloading. Okay. This is a little bit strange, -p and -p again. It's a 2 port. We need to have a compose file for this. Actually, I need to put it in the DB stuff. We can add this portainer here. So yeah. Actually, I will do it now so we don't forget about it. This would be, well, then you can okay, it's done in my deploy branch. Okay, perfect. Okay. It's finishing downloading. Okay, perfect. Now I need to go to 8000. Let me localhost 8000. No, it's not working. 8000. 9. 9443. Client send HTTP request on HTTPS server. Let's see if Chrome, because but well, it's some config. Yeah. Later on we can show it in the next live stream, so it's not a big deal, but it's just a monitoring tool to it's a configuring thing. It's a monitoring tool to see the containers. That is really convenient. So well, that's basically all. We are still running the screener. So just to recap a little bit what we did. We first of all, in a notebook, we define the universe of markets, we download the candles, we compute the metrics, we join all the results, and then the missing part is to send the report. Right now we're just logging the value, but it's just a matter of time that you can go and include that in your branch. So well, I will push these changes. I will create a custom screener report runner. I will clean up this and I will push to a branch so you can see the code, and then you can start playing around with the Jupyter notebook, adding more features to it, and then translate that into a runner and start sending your reports. So well, that's basically all. I hope that you like it. Well, see you next Friday. That we're going to continue with this live stream style where I can code what the community wants. Well, that's basically all. Thank you very much, and see you next week. Have a great weekend.